Welcome to all. Welcome to all. Myself, Tanu Gupta, Assistant Professor at Information Technology Department at Akgec Engineering College, Ghaziabad. Today, I am going to discuss a very important topic in Python programming, that is Numpy, which is a Python library. Basically, Numpy stands for Numeric Python, which is a Python package for the computation and processing of the multi-dimensional and single-dimension array element. Basically, Numpy is used for the computation of single-dimensional and multi-dimensional array element. It provides various functions which are capable of performing the various computation with a high speed. Numpy performs an array-oriented computing, efficiently implement the multi-dimensional array. It also performs a scientific computation. It is capable of performing Fourier transform and reshaping of array element in a efficient way. It also provides a many inbuilt function for the linear algebra. Now continue. Numpy does not come bundled with the Python. We have to install using the Python pip. It does not comes bundled with the Python. We have to install Numpy pip installer to execute the following command: pip install Numpy. First, we have to install this command in your system. Then we are able to handle the Numpy, which has a variant feature and which can be used for the programming. So Numpy ND array. ND stands for n-dimensional. ND array is the n-dimensional array object defined in the Numpy, which stores the collection of similar type of element. As in array, we have to collect a element of similar type. For example, if the element is of int, then all the element would be integer type. Other one is a float type, or we can say a character type. So all the element is a collection of a similar data type. What we can say, an array is a collection of similar data type. It can be a int, it can be a float, it can be a character, and so on. In another word, we can define an ND array as a collection of data type. In short, D type object. Another one, the ND array object can be assessed by using the zero-based indexing. As in the array, the indexing should be started from the 0th index. If we have an element, if we have an array of name A and we have the 5 element 1, 2, 3, 4, 5. So the indexing of array element of first should be started at 0. The first element at index 1. The third element is at index 2. The fourth element is index 3. And the fifth element is at index 4. So if we have to find out the element at 3. So what we have the answer is? The answer is 4. Okay. Now continue how to create an ND array object. The ND array object can be created by using array routine of the multiple module. For this purpose, we have to import the Numpy. If we are using the features of Numpy, first we have to import the Numpy, stand for numerical Python. Import, we have to write the statement import Numpy as NP. Now in further programming, we are going to use Numpy as NP. Okay, then A is equal to NP dot array, NP numerical Python dot array, and print A. So what we have answer? We can also pass a collection of object into the array routine to create an equivalent n-dimensional array. The syntax is given below. A numpy.array, or we can write a np.array. Object D type is equal to none. D type data type. Data type आपका none. Copy is equal to true. Another attribute is order is equal to note. Subbook false, and end in dimension. Dimension is equal to 0. So this is a syntax for an array object. How to create an ND array object? We have the following attributes. These one are optional and this one data types is a compulsory object. Okay, so this is the explanation for the ND array object. First one is a object. As we discussed in the previous slide, these are the syntax for the for creating a ND array object. Then what is defined the object? It represents the collection of object. Object is identified by the collection of object. It can be list, it can be tuple, it can be dictionary, etc. Second one, in the syntax of creating an ND array object, second parameter is a D type. We can change the D type of the array element by changing this option to the specified type. The default is none. If we are not going to mention any D type of the array, then the default is none. If we want to change the D type data type of the array, then we have to mention on it. Okay. Third one, copy. It is optional. It is optional. By default, it is true. The parameter of copy, it is optional. You want to write on the when creating an ND object, you can write. It is not compulsory to write a copy parameter of an object. You can skip of this. It is optional. By default, it is true, which means the object is copied. The another parameter is order. There can be three possible value assigned to this option. It can be C, column order, row order, and A for any. Okay. The another object of, we can say, a parameter is subvoc. They return array will be base class by default. We can change the value of subclass by passes by setting this option is equal to true. Okay, and the last parameter is ndim. It represents the minimum dimension of the resultant array. So these are the parameters which we use to going to create an ND object or to create an n-dimensional array object. Okay, so first we have to take an example, then we have to explain the example related to this array. To create an array, in the first example, to create an array using a list, we use the following index. If we are going to use a list and we have to create an array, so what will be the syntax is A is equal to numpy.array 1, 2, 3. 1, 2, 3. We have to take a list in which there are 3 elements 1, 2, 3, and we are going to show this for an array. So what we have to write? numpy.array. Within a list there are number of elements. For example, in this example we are going to use 3 numbers 1, 2 and 3. To create a multidimensional array object, we use the following index. If we have to use a multidimensional array, or we can say 2-dimensional array, 3-dimensional array, then the syntax will be like this. This is for 1-dimensional array. If we are going to use 1-dimensional array, then we have to mention only one list. If we are going to use 2-dimensional array, we have to find our 2 list. Okay. In the first list, 1, 2, 3, and in another one, 4, 5, 6. To change the data type of the array element, mention the name of the data type. If we want to change the data type of the array element, we have to mention the data type. When we have not mentioned the data type, the default will be a none. If we want to change the data type of a given array, then we write a parameter D type is equal to, it could be an int, it could be a float, it could be a complex. So in this example, we are going to change our data type from integer to a complex. So what will be the result? 1.0, 2 plus ij, 3 plus ij. So it would be converted into a complex data type. Okay. The next example we have to take, the ndim function can be used to find the dimension of the array. So first we have to import the numpy as np. Then we have to create an array in which there are these elements 1, 2, 3, 4, 4, 5, 6, 7, 9, 10, 11, 13. Print ar.ndim. We have to print the dimension of this array. So what will be the dimension of this array? It would be 3. So ndim is for dimension, array is in parameter that we have to pass in this, and after that we print an array. So this is a syntax for finding out a dimension of an array, or we can say to how to create a single dimension array and how to create a multi-dimensional array. And after that we are going to use this type of array for finding the n dimension of array. Okay, finding the data type of each array item. If we have to find out the data type of each array element, so what will be the syntax of the program is, first we have to import numpy as np, because we are going to use the features of numpy numerical Python in our program. So first we have to import a numpy as np. Then the second step is to create an nd object. It can be either one dimension or two dimension. In our case, it would be an one dimension array object. Then np.array 1, 2, 3. We have to create a list in which n 3 element 1, 2 and 3. In the second step, we have already created an n dimension of array object. Now print. Each item is of the type. So what will be the output of this program? 1, 2, 3 of which data type? Okay. Then when we have to run this program, the output will be each item is of the type integer 64, because 1, 2, 3, 4 could be an data type of integer. So the output will be an integer. And what the syntax for finding out nd type of an array element? A, because all the elements are going into an variable a. So a dot d type. So when we have to put this syntax, all the element in that array are going to produce the output, what will be the data type of this and all the element of array. So all the element in the array is of integer type. Clear? Now in the second program, we have to find the shape and size of the array. Okay, now we have to create a program in which we have to find the shape and the size of the array. So first we have to import numpy as np. Then we have to create an array list in which we have to find out the shape and size of the array. So first step, import numpy as np. Second step, as similar to previous, create an nd array object. Then what we have to calculate? Shape or size. Then size and shape. So array size, a dot size, we have to mention like this, a dot size, because the list is under the variable a dot size, and for shape, a dot shape. So the output will be array size 7. 1, 2, 3, 4, 5, 6, 7. Because there are 7 elements in this. So the array size will be 7. And what is the shape of this array is 1, 7. Shape 1 dimension and there are 7 elements. Okay. So the shape of this array is 1, 7. So this will be the output of the program. If we want to find out the size of the array, then the size of the array is 7, because there are 7 elements in this. If we have to find out the shape of the array, then the output will be 1, 7. Okay, next, how to reshape the array object. First, we understand how to install a numpy array. After that, how to create an n-dimension array object. Then we have to find out the size, or how to find out the shape of an array. Now comes to the reshaping of the array object. If, for example, if we have an matrix of 2 cross 3 size, we want to reshape it. Okay, suppose we have an array of 2 cross 3 size, 2 rows, 3 columns. We have to reshape it. So what will be the output is 3 columns and 2 rows. Just reshape. Okay, 2 cross 3, then the output will be 3 cross 2. 3 rows, 2 columns, 2 columns, 3 rows. So what will be the output, or what will be the syntax of this program is, first we have to understand by the shape of the array, we mean the number of row and column of the multidimensional array. However, the NumPy provide us a way to reshape array by changing the number of rows and columns of multi-dimensional array. We have a feature to directly convert rows into column into rows. As in other language like C, we have to create a 5 to 6 line program to reshape an array. But in the Python, we have direct features. We have a direct function, or we can say a method, that is a reshape. We are directly going to use in this program. So when we are going to input a 2-dimension array or 2x3 matrix, we got the output of 3x3. So what will be the program of this program? Import numpy as np, because we are going to create a reshape feature of numpy Python package. A is equal to np.array 1 cross 2, 3 cross 3, 4, 5, 6. So input will be 1, 2, 3, 4, 5, 6. So matrix will be of type 3 rows, 2 column. Okay. So printing the original array, we have the output like this. Print A. When the statement comes out print A, this matrix will be print. After that, A is equal to A dot reshape 2 parameters हमने provide किए 2, 3. Then printing the reshape of the array. Then what will be the output? 1, 3, 5, 2, 4, 6. 2 rows, 3 columns. So what will be the output of this program? If we input an array like this, then after reshaping, the output will be like this. So in the Python, or in the numeric Python NumPy library, we have a direct method reshape to convert the rows and columns of the matrix. Okay. Now another program we have to consider, finding the maximum, minimum and sum of the array element. Okay, what is in the question? We have to create a list, after in which we have to put on the element, then we find out the maximum, minimum and sum of the array element. So what will be the procedure is, first we have to import a NumPy. After that we have to create a list of number of elements like 5, 10, 12, whatever you want. Then print an array. After that, what will be? We have a method, direct method for finding out the maximum element, max. For finding the minimum of an element of an array, we have a direct method, minimum. For finding out the maximum value, we have a method maximum. For finding out the minimum value, we have a function minimum. And for finding out the sum of the element of the array, we have a method sum. So there is no need to calculate or maximize, or we use a if else statement like as we use in the C for the sum. First we have to create a for loop for 1 to n. N is the number of element in the array. Then if we have to calculate the sum of the element, we are going to use the statement sum is equal to sum plus I, and then to print. There is no need to write down so many steps like in C. But in Python, we have a number of various features or method which we can use directly in this program. So what will be the program like this? Import numpy as np. Then we have to create an array or a list in which we have 1, 2, 3, 4, 5, 6 element, 1, 2, 3, 10, 15, 4. Print the array A. So from this statement, this lit are going to be print the maximum element. What is the maximum element in this list? Is 15. So directly we are going to use a.max. The output of this statement will be 15. Then in the next step, the minimum element, what will be the minimum element of this list? 1. So the output will be for 1. Sum. What will be the sum of this program? That contain all the letters sum. 1 plus 2 plus 3 plus 10 plus 15 plus 4. What will be the output? The sum of the element is this. Okay. So this is a simple or basic program in Python in which we have a functionality to use direct methods which are going to use in this program, and there are various features in Numpy Python library which are directly used in this program. No need to write down so many statements like in C 5 to 10 statement. There are simple just 5-line program in the Python which are we show. Okay. Next, Numpy array access. In the Numpy access, we are going to show Numpy array access. This one access 0, and we have to denote access 1 like this. If we are going to show access 0 and access 1, then this one will be the access 0 and access 1. A Numpy multi-dimensional array is represented by the axis where axis 0 represent the column. Axis 0 represent the column. And axis 1 represent the row. If we are mentioning axis 1, then we are going to use a row. If we are mentioning axis 0, then we are working on column. Clear? If in the program, if we are writing axis 1, then we are going to discuss on row, we are working on row. If we are writing axis is equal to 0, then we are working on the column element. Okay, so we can mention the axis to perform row level and column level calculation like addition of row and column elements. So let us take an example to understand the concept of axis 0 and axis 1. So in this program, to calculate the maximum element among each column and the minimum element among each row and the addition of all row element, consider the following example. So what we have to exactly do in this program, first we understand. To calculate the maximum element among each column. Suppose we have elements in the array like this. To calculate the maximum element among each column. So what will be the maximum element in this column is 3. In the second column is 6 and in the third column is 9. Okay. The minimum element among each row. So what we have to find out? The minimum element among each row. That will be 1, 2 and 3. We have to find out the maximum element among the column and the minimum element among the row. And the addition of all row element. And the addition of all row element. 1 plus 4 plus 7, 2 plus 5 plus 8, 3 plus 6 plus 9. So what will be the code of this program? It will be like this. First consider. First we have to import numpy as np. Then a is equal to np.array 1 to 30. For example, 1 to 30. Then another list is 10, 15, 4. 10, 15, 4. Okay. Print array. So the array will be printed. Now the maximum element of column. Maximum element of column. So what we have to write a method. If we are going to discuss the column, then we have to write axis is equal to 0 as we discussed in the previous slide. A.max. Because in the question, we have to find the maximum element among each column. Maximum element, for maximum element, we are going to use a max function. And we have to find the maximum element among each column. So in the Python, if we are going to use a column, we have to write axis is equal to 0. Okay. So what will be the output of this program is 10 maximum of this column, 2 and 15 maximum of this column 15, 30 and 4 maximum of this column is 30. So the output of it would be 1, 2. Next statement, the minimum element of row. Now we are going to find the minimum element of the row. So for finding out the minimum element, we are going to use a minimum method. Okay. And for row, we are going to use axis is equal to 1. So in this, if we are going to mention axis 1, 1, 2, 3, the minimum of this row is 1 and the minimum of row, second row is the 4. So the output will be 1 and 4. Clear? Third statement, the sum of all row. So in the program, then the third, what we have to find the addition of all the row element. Summation, or we can say a sum of all row. 1 plus 2 plus 30. What will be the output? 33. 10 plus 15 plus 4. What will be the output? That is 29. So the sum of all row be like this. So this is a code for the above example. Clear? One point that you have to remember, if we are discussing about the column, we have to find the minimum, maximum, or whatever the thing we have to calculate. For column, we are going to use axis 0. If we are considering about the row, then we have to mention axis is equal to 1, whatever you using the method minimum, maximum, sum, average, whatever it would be. Okay. Now come to the next program, finding the square root. If we have to find the square root, then we have a direct method, that is SQRT. We have a SQRT function in the Python, or we can say a numeric Python, which we are going to directly use in our program. First, as similar, we are going to import numpy as np because we are going to use the features of numeric Python. After that, creating an n dimension object, it would be a 1 dimension, 2 dimension, or 3 dimension. Then print np.sqrt because we have to find the square root of the matrix element or array elements. So we are use the SQRT method for creating on the object we have to create in the previous step. So what will be the output of this program? The square root of 1, square root of 2, square root of 30, 10, 15 and so on 4. Okay, so we are directly use the SQRT function in our program. Now let us consider another program in which we have to find an arithmetic operation on an array. If we want to operate like arithmetic operation, addition, subtraction, multiplication, division, then what will be the code of the program? What will be the step? First, we have to create a numpy object. Then we have to create a list or we create a n-dimensional array object. And we have to perform the addition or subtraction. So we are going to use a 2 array. Okay. So first we have to create an array, for example, A and B. And then we have to find out the summation, subtraction, product and division on the array element. So first we have to import numpy as np. Then in the second step, we have to create an n-dimensional object 1 to 30, 1 to 30, 10, 15, 10, 15, 4. Then in the third step, we have to create another matrix. What will be the element of 3, 1, 2, 3, 12, 19, 29. And we have to perform the arithmetic operation on both the matrix. First, we have to calculate the sum of the array elements, or we can say sum of the element. So, what will be the output? 1 plus 1, 2, 2 plus 2, 4, 3, 30 plus 3, 33, 10 plus 12, 22, and so on. Okay. As similar, if we have to find the product or division of the array elements or performing an operation on the matrix element, we are going to directly use the addition subtraction functions. Okay. Now, array concatenation. The Numpy provide us with the vertical stacking and horizontal stacking, which allow us to concatenate two multidimensional array horizontally and vertically. Also, Numpy also provide a features that is vertical stacking and horizontal stacking, like 1, 2, 3, 4, 5, 6, 7, 8. Suppose, for example, we are going to use to perform a vertical stacking and horizontal stacking, which allow concatenate of two-dimensional array horizontally and vertically. Okay, so what will be the code of this program? First, we have to import a Numpy. Then we have to create two array, A and B. Now, np.vstack, we have to concatenate these two array. If we want to concatenate these two array, then we have to write np.vstack, that is vertical stack. And after that, we have to find out an h stack, that is for horizontally stack. Then in vertical stack, the array will be on vertical stack, and on the h stack, the np.h stack, that is horizontally concatenate this array. Okay, so let us take an example. Import Numpy as np array in which has element 1, 2, 3, array 2 element 4, 5, 6, np.concatenate array 1 and 2 and print. Then these both elements, or we can say an array, would be concatenate, and the output will be 1, 2, 3, 4, 5, 6. Thank you.